Assalamu alaikum wa rahmatullahi wa barakatuh. Hello, grade 8. I want you to bring your book and open page 285. Today our lesson is about mid-segments of triangles, and this is the first lesson in chapter 5. Okay, in this lesson you will use properties of mid-segments to solve problems. So the question is, what is the meaning of mid-segments of triangles? Mid-segments. Mid-segments. Let's read the definition here of the mid-segment of a triangle. A mid-segment of a triangle is a segment connecting the midpoints of two sides of the triangle. So here DE, look at this triangle. DE is, we call it what? We call it mid-segment. Why? Because here it's a segment connecting the midpoints of two sides of the triangle. So DE, we call it what? We call it mid-segment. Okay, let's read. There are two special relationships between a mid-segment of a triangle and the third side of the triangle. Let's see here. In this theorem, which is triangle mid-segment theorem, let's read the theorem. If a segment joins the midpoints of two sides of a triangle, then the segment is parallel to the third side and is half as long. So you will understand that DE is parallel to what? To AB. And DE always half of AB. Okay? For example, if AB is 10, then DE is 5. Okay? If DE is 2, so AB of course will be double it, so 2 times 2, which is 4. Okay? This is the triangle mid-segment theorem. Let's see next. Page 286. Let's see problem 1. Identifying parallel segments. What are the three pairs of parallel segments in triangle DEF? Okay, I want you to look at this triangle. Here we have the first pair. First, this is the mid-segment RS. So RS is parallel to DF. This is the first pair, yeah? And then, what is the second pair? TS is parallel to DE. This is the second pair. And then what is the third pair? RT is parallel to EF. That's it. Okay. About garden number 1, we will skip because we don't have the triangle. Let's see question B. What is the measure of angle VUO? Where is VUO? VUO, this one. In the figure at the right, explain your reasoning. Okay, because the pairs here, because VU is a mid-segment, and VU is parallel to MN, we took before that what? Interior angles are corresponding here. This is corresponding to this. So we can say that measure angle VUO is equal to measure angle MNO. So the answer here is 65. Okay, that's it. Let's see next, page 287, problem 2. Finding lengths. Okay, in triangle QRS, TU and B are midpoints. What are the lengths of TU, UB, and QR? Okay, so they want what? TU, which is which is what? Parallel to this. And we know that from the theorem, this is half this. So if this is 40, then TU is what? Is 20. Okay? And then the other pair, they are asking about UB. So that's it. This is UB, which is parallel to QS. If QS is 50, then UB is half of it, which is 25. That's it. And then QR, they are asking about QR. So QR, this one. This is missing. They give us that TB is 30, and by the theorem, TB is half of this, and QR is double of this. So if this is 30, then this will be, of course, double it, 30 times 2, which is 60. Very easy. Let's see, got it, number 2. In the figure at the right, AD equals 6. They give us this. AD equals 6. And DE, they give us also this one. And they give us also, okay, AD equals 6 and DE equal 7.5. What are the lengths of DC? I'll put it with red. DC. Okay, so if AD is 6, then of course it's clear that DC is what? Is also 6, because D is a midpoint. And then AC, what is AC? The big one here, this one. Of course, this is 6 and this is 6, so AC will be 12. What about EF? This is also missing. If you know the big one, AC, can you find EF? Of course, yes. EF is half of AC, which is 12 divided by 2, which is 6. And then, what is AB? This one. If they give you DE, can you find AB? Of course, DE is 7.5. So what is AB? 7.5 times 2, which is 15. That's it. Okay, let's see problem 3. Using a midsegment of a triangle. A geologist wants to determine the distance AB across a sinkhole, choosing a point E outside the sinkhole. She finds the distance AE and BF. She locates the midpoint C and D of AE and BE, and then measures CD. What is the distance across the sinkhole? So, I want you to look at this triangle here. DC is what? Is a midsegment, is it right? And this midsegment is of course parallel to this. So if I have the measure of the midsegment, can I find AB? Of course, yes. Very easy. Because by the theorem, this midsegment is half of this. So if I have this one, can I find the big one? Of course, yes. How? Double it. That's it. If they said that CD is what? 46. So to find AB, you will double 46. So you will multiply 46 times 2 to get the answer what? 92. Okay, girls? Let's see, got a number 3. Here we have, CD is a bridge being built over a lake, as shown in the figure at the right. What is the length of the bridge? I want you to look at this triangle. Okay, they give you, okay, they want the length of the bridge, which is CD, and they give you the length of the parallel side, which is 2,640 feet. How can I find CD? Of course, by the theorem, you will divide by 2 because it's half of it, yeah? So divide the answer, divide the number 2,640 to get 1,320 feet. That's it. Let's see the last question in this lesson. Question number 6, error analysis. A student sees this figure and concludes that PL is parallel to NO. What is the error in the student's reasoning? Okay, so here, I want you to look at this triangle. They put the mark, this side is equal to this side. That means P is a midpoint. But can you tell me, here, L is a midpoint. Can we say that L is a midpoint? No, is it right? Why? Because they didn't put the mark. They didn't put this mark. So here, the answer is the student is assuming that L is the midpoint of OT, which is not given. That's it. So this is for today. See you tomorrow.